Hey guys, welcome to this live stream. I hope you're doing great. Welcome to today's live session of World Physics Festival. Sorry for bad quality. While today I'm gonna tell you briefly about gravitational waves, what they are, and how they were discovered, taking as less as possible time of yours. So, let's start. As you all know, and if you don't, gravitational waves have finally been detected in 2015 by a very successful team. So, what are gravitational waves? Nice question indeed. Back in 1915, Albert Einstein gave the world his new theory of gravity, the general theory of relativity, which is based on a beautiful idea that gravity is nothing but warps and curves in the fabric of space-time. Now, barely a year later, Einstein pushed this idea one vital step further. You see, he realized that if space is flexible enough to warp, then it should be able to ripple, to vibrate, to undulate, and that would mean if something were to jostle the fabric of space-time, it should send out ripples in the fabric of space, and it's those ripples that we now call as gravitational waves. Now, definitely, the sources of these waves won't be any ball or my hand. Instead, it would be some highly energetic astrophysical processes like rapidly orbiting neutron stars or black holes that will send out a steady rumble of gravitational waves. Or at least, this is what theory says should happen now. So, how they were discovered? Well, as this is happening far away in space, which makes it difficult to discover, but as gravitational waves roll by, it will squeeze and stretch anything in its path. So now, those this can I'm gonna so this this stretch and just squeeze of this Earth won't be on like a astrophysical center of Mars and like not like that, but this whole thing is gonna be really precise. So we can do the calculation by the universal formula of gravitation on the screen, and you find that amount of squeezing and stretching would be tiny, a mere fraction of an atomic diameter, and that makes it pretty difficult to detect. But that is what the LEGO team has now achieved. And they did it with two detectors, one in Louisiana, the other in Washington State. And then these detectors, what they do is fire laser beams along 2 4 kilometers long evacuated tunnels, and when the light recombines, it creates an iconic pattern. It's known as an interference pattern. But the only thing that you need to grasp is that gravitational wave to roll by will squeeze and stretch the arms of the detector, and that would have a miserable impact on the interference pattern, causing it to shift. And just that kind of shift in the interference pattern that the LEGO team has observed, the first detection of gravitational waves. And this is big. This will go down in the history of science as a pivotal moment, and not just because this is another spectacular confirmation of Einstein ideas, which it is, but rather because for millennia we have explored the universe using our waves of light. This discovery marks the opening of a new era in which we will explore the universe using waves of gravity and with Einstein ideas. If you've got any value out of this video, so do consider subscribing and liking the channel for more such informative stuff that will motivate me to make more such videos. Yeah, so by that time, stay healthy and keep studying anything you like, physics or anything. So by that time, bye. So see you in the next video. Bye guys.